dun, 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 dun. All right, that's up and running. Excellent. Okay, so good afternoon, everybody. Welcome to 15 minutes later, right? I got that whole shifted schedule for today, but we won't let that throw us off, okay? We've got bigger problems to solve than simple schedule malfunction, right? In fact, specifically, we've got a problem set of some nice mathematical problems to work through for today. So this video is going to be rather short, since I'm just going to run through a couple of hints for the first three problems that comprise that level 1 problem set. If you finish those and you have time, I do encourage you to go on to level 2. The level 2 questions all do go together, and they kind of extend from one of the level 1s. So it's not all that much more effort if you can find the similarities between them, okay? So let's have a look at some of these, shall we? We've got equilateral triangles here. How many equilateral triangles of all sizes are there in the 3 by 3 by 3 equilateral triangle shown next? And they add this additional note on definition of equilateral triangle because it hasn't been formally presented in the text. Remember, this is a full geometry book. It'll get to all those vocabulary words in turn. That's a good reminder there. So this sounds very much like the question we actually did yesterday with the squares. How many squares can I draw here? Except this time the shape is a triangle. So my hint for you to get started would be to work on drawing all possible sizes of triangles, right, that are pieced together. You can see here, as it is shown, this is one big triangle, but it is 1, 2, 3 triangles tall. So what different sizes of triangles do you need to look for? How can you account for those? Draw some pictures. Look back at our work from yesterday's example problem with the squares to see a very similar problem, and hopefully you can use a very similar solution, okay? It's all part of why we practice these things. Next up, we've got number 3 deals with a tetromino. Oh, I love tetrominos. You may be more familiar with the dominoes, do-minos, right? 2 squares side by side. So a tetromino is 4 squares all connected together. It would be really fun to try to play some kind of domino game, but with tetrominos. Or maybe there's some kind of like a puzzle game that you could try to fit a bunch of tetrominos together. That sounds like a really cool video game. I should write that down. If nobody's made that yet, I can make a bunch of money. But my hint for you to figure out what all possible tetromino shapes there are with this question would be to start with one block. Start with a single square and figure out how many different ways you can add on to that square, right? We can add another square onto this side or the other side, top, bottom, right? How many ways can I grow this out and not end up with a shape that I've already gotten before? So that would be one way to help you keep track of that, right? And then the third level 1 problem, question 10 from the text, says, determine if exactly 6 squares of the 3 by 3 grid shown can be shaded so that no 3 shaded squares line up horizontally, vertically, or diagonally. Right? So this, you break out the crayons and you start coloring in the squares as you go, and then you realize, oh wait, shoot, That's 3 in a row, right? I can't have that. Do not make tic-tac-toe with your colored squares. So you're going to try to find a way to avoid doing that. And if that proves difficult, because there's too many things to keep track of, my hint for you is to instead consider the empty squares left behind. If I color in 6 squares out of 9 total, that means there's 3 blank squares left over. In fact, we already have a similar problem from the text in the Draw a Picture section. Let's take a look at that here. Strategy number 1 was draw a picture. They gave us the example of the cubes here, and then 2 additional problems where it was useful included this square with the diagonal. And the second one, a rectangular milk crate, has spaces for 24 bottles in 4 rows, 6 columns. So again, it's a grid of squares. We've only got 18 bottles to fill 24 slots. So how are they arranged there? Very similar type of problem. See if that solution will help you out on the other one over here. Hey, any major questions at this point? No? All right. Then, like I said, short and sweet. I will leave you with the rest of the class period to work. You got lots of time. Go ahead and tackle these to the best of your abilities. If you get stuck, feel free to send me a message or an email to get some help. I'd be happy to give you a little more guidance to help you along if necessary. Really want you to get at least those 3 down. And then if you can, try to go on. Here is the first level 2 question, goes on to a pentomino. Well, now we got a 5 square piece, so we're literally leveling it up as we go. So that's a fun little extension there. Give it a shot, all right? See what you can make of it. The worst thing that will happen is you don't get an answer. That's literally the worst thing that can happen, okay? It doesn't get worse than that, so don't sweat it. I will leave you with that.